Hi everyone. So today I just wanted to quickly show you guys this project that I've been working on over the past 3 or 4 weeks or so. And yeah, this project I decided to call it the Fragile Store because it's a project where I decided to systematically break production systems just to understand how they fail. And here's what I learned from working on this project. So my approach to this project was that I feel like most tutorial videos and most infrastructure tutorials, they show you how to build things that actually work. But when it comes to production, systems do fail in ways that these tutorial videos don't show you. So yeah, that's why I decided to build this project. It's something that is deliberately fragile for me to learn from how they break. And yeah, so the fragile store, it's basically like a cloud native, as you can see on the diagram. It's a cloud native e-commerce API that is designed to break under stress. And yeah, as you can see from the diagram, this is a real AWS infrastructure, which I deployed in the EU North region. I don't know why I did that because I'm in South Africa. So that was the first lesson that I learned. So I decided to fix that. But then, yeah, it has a proper VPC as you can see with the public subnet and the private subnet. Our net gateway is over here, and we got our MySQL RDS MySQL database over here, and also an app server with a Docker container inside. And I feel like these are everything that you will normally see in production. But as you can notice on the architecture diagram, we got this exclamation marks here that I pointed. And these are the four critical failure points that I systematically triggered. And yeah, I basically wrote them down over here in a little notepad. And yeah, over multiple sessions that I've been working on this project, I deliberately broke the system just to understand the production failure patterns that costs enterprise millions. So yeah, today I just want to demonstrate a few because I don't want this video to be too long. I'm just gonna demonstrate 2 or 3 of these critical failures and just show you exactly how they behave, exactly how I prevented them, and how that could be of value in companies, and yeah, just basically how to prevent them in production, in infrastructure productions. All right, so without further ado, we'll start with our first one, which was actually the most important one in my eyes, which was the zombie containers. So it's over here, as you can see on the architecture diagram. I will demo it just now. I just want to show where we start. The app server over here. That's where our Docker container was. And yeah, looking at the architecture diagram, it's over here. And this happens in a private subnet where the Docker container runs on an EC2 instance. All right, so now I will just demonstrate that quickly over the terminal. All right, so before I decide to deploy the container, I just wanted to show you guys what I wrote on the app server and yeah, what actually happens in the back end for me to actually notice this, for me to trigger these failure points. So here we got our workspace. On the left side, we have a terminal where I'm going to, well, for now, I'm going to show you the node app server. And then on the right side, that's where we're going to see all the error messages and all. So if I show you the back end app server, we got 3 endpoints which I wrote for me to experiment these, or for me to watch these in actions. And the first one is the leaky endpoints, where is an endpoint that I decided to write where I create a connection pool with only 5 connections because I wanted it to be aggressive. And then these connections are not returned back to the pool. So after trying to access these endpoint 5 times, there won't be any connections left, the connection pool will be exhausted, and ideally the app will hang, and yeah, it's going to be unresponsive. And then the next endpoint is the pool status, which shows us it's a status where an endpoint where roads to just monitor the status of the connection pool, how many connections we've used, how many connections are left, and the amounts of connections in the queue. And there's also some logs that we will see just now where it shows us what actually happens with each and every connection um, in the pool that are used. Each leaky connection, if I can say. And then the third endpoint, who is the health endpoint, but I will talk more about this later on. All right, so let's get started with the Docker, the zombie container. All right, so first I'm going to run a Docker. I'm going to create a Docker image. Hold on, let me just see if it's already been created. No, it's not created. Okay, perfect. Um, I'm just going to speed this up or just skip over this step. All right, now the Docker image has been created. I'm going to show you guys I'm going to run the container first with memory limited to 128 megabytes and half a CPU. Just to show you guys what I mean by that. Ports 1, 2, 3, 3000 with the memory of 128 and CPUs of call it fragile store. Ugh. Sorry. Oh, I see. I forgot to say Docker run. All right, so we'll run our Docker container with all right, so we'll run our Docker container. All right, perfect. So as we can see, our server is now running, the Docker is now created. And if we can now, on the right terminal, we're going to see the connection pool status that I was talking about. First, let's see if our server is actually up and running in our container. Yeah, it is up and running. So we're going to first, now we're first going to send a request to the pool status to see that the connection pools are now, let me just show you guys. There. There's 5 connection pool. Like I said, I wanted it to be aggressive. I wanted it to be after the sixth connection, the app hangs and to see that the app crashes and becomes unresponsive. And now I'm going to send requests to the actual leaky connection. I mean the leaky endpoint. Endpoint. Yeah. As we can see now, all our connections have been used. Oh, no. I meant to do this 5 times actually. So the first time it says leaked connection, the first one's gone. The second one, used, connection leaked 2, connection leaked 3, connection leaked 4, connection leaked 5. So that's all of our connection leaked. So right now the connection pool has no connection. So if I call this one more time, the app should start hanging now. And yeah, there we go. We can see all the connections have been used, and now there's just complete silence. There's no response. There's no errors. There's nothing. The app is dead. But if we now go back, if we decide to end this, let's do it this side. Yeah, we decide to stop this and to check our Docker container. We can see. Let me just put this and enlarge this. Yeah, we can see here that everything is fine. We can see everything is fine here. This I feel like was the terrifying part that I discovered, that Docker still shows that our container is up and healthy, but then we just saw that our container. Yeah, but we just saw that our container was dead. I mean, our app was dead. It was unresponsive. Nothing was happening. And yeah, this is the worst possible failure node, I think, because in productions, you monitor your dashboards, your developers are watching and seeing that everything shows green. Your load balancers will keep sending traffic, but every single user request will time out indefinitely. And I feel like this is a major problem, and I call this like a mysterious outage, if I can say, because your junior developers will be confused. Your junior developer will start panicking. They're like, "What's going on? There's no error messages," and I can understand because this is incredibly hard to debug. Because all your tools that you set up will lie to you. Your container, your Docker container will say, "Yeah, it's up and running. It's all green," but then on the underlying parts, it's actually an app that's no longer running. And to prevent this, as I was telling you earlier, I wrote the health endpoint as well. And I'm going to show you guys once more the health endpoint in the app. Yeah. So the health endpoints was the solution that I came up with to this problem. It's a resource-aware health check that doesn't consume the resources that it's monitoring. So with most health points, you get health points that use a connection, but then the connection has already been used. I don't know if I'm making sense, but then you get health points that lie to you that says, yeah, everything is up and running because it's trying to use a connection when there's no connection in the pool. At least that's what I experimented. So I decided to write this health points, which it's resource aware. Okay, it knows what's going on without consuming its resources. And yeah, so this is what I decided to write. I'm not gonna go over it. I'm just demoing it. So I'll show you what happens when I hit the health endpoints, even though our app has been is not responsive. If mm, All right, so our Docker container is still up and running, but then we know that there's no longer connections available. The app is unresponsive. It has crashed. It's in a zombie state. But then when we hit the health endpoint that I was telling you about, we can see that we hit error 503 immediately, that the connection pool has been exhausted and the service is unavailable with pool exhaustion details, as I was saying. So this health check inspects the connection pool state without trying to use a connection itself. And this tells load balancers to immediately stop sending traffic and preventing a silent failure cascade like we just saw earlier. And yeah, so this was the zombie container failure mode that I've experimented, and now I want to show you guys the second critical failure mode that I experimented. All right, so for the next failure point that I discovered or that I experimented, I'm going to show it to you guys now. I'm going to demo it, but it's basically how AWS networking can silently break your application. So as we can see in the diagram, the architecture diagram right now, you'll notice that the NAT gateway is correctly placed in a public subnet now, but it wasn't always like that. And I'll show you guys initially the mistake that I made, which I think it's a classic mistake. Yeah, I'm just going to live demo it to you now. I did fix it. It wasn't like this before. I'm demoing this failure now, but I'll just show you guys um exactly what I did. So I placed the NAT gateway in a private subnet. So this is initially what I did, and I'm going to show you exactly that because that I'm demoing this now. So I placed it in a private subnet. I like an IP address. I did do that, and yeah, I'm just going to fix the VPC as well. Add it to the root table. Um, all right, perfect. It should work now. Okay. All right, so I'm just going to demo exactly what I did, the rookie mistake that I did by putting the NAT gateway in a private subnet, and the symptoms were completely misleading. It was actually frustrating because this was one of the era where I didn't know what I was doing. I just discovered on the go. So the application will hang indefinitely at startup. So I could connect to the Bastion host. Actually, I think I'm going to have to restart this. Okay, yeah, let me do that. Let me just pause and restart because here I'm on the fragile, the second instance. I'm just going to. All right, so I actually don't have to restart it. I'm just going to show you guys what I made if I try running the starting the what am I trying to say? Starting the database, okay? Or the application server. As you can see, the application just hangs indefinitely at startup because the NAT gateway is now in a private subnet and not in a public subnet. The app won't even start. And this was confusing because I thought, okay, if I can reach the Bastion host and, surely my instance will have internet access from the Bastion host. But that was the critical insight. Apparently, I learned this that the Bastion host connectivity doesn't mean application internet access, but the NAT gateway must be in a public subnet to route private subnets to the traffic to the internet. It took hours, and I mean hours, to debug this. I really almost gave up on this project because of this simple mistake on my side. But yeah, it took hours to debug because the symptoms were so misleading. I did not know what was going on. And yeah, as you can see, the app is not even starting. If I try connecting to the database, or try sending a request, goes 2000. Yeah, you can see it's failing to connect. It was so frustrating. But then eventually, yeah, I figured it out that, once I moved the NAT gateway to the public subnet and fixed the routing table, like I just did, everything worked. But then, yeah, I feel like this failure really told me that AWS networking fails in subtle ways that can completely halt deployments. Like it can be really frustrating because it's a small mistake. It's like when you're coding, you forget a semicolon, and we know how that can be annoying. It's a small mistake that you don't notice, and you reach endpoints like this where you just want to give up. But yeah, this was the second failure mode that I just wanted to show. That really taught me a lot about the AWS networking. All right, so for the final failure point that I'm going to demonstrate in this video is database connections, which I think is the heart of most production failures. Looking at our architecture diagram, we have an RDS MySQL instance with 75 connection limit. This might sound a lot, but you will see how quickly we can exhaust it. Um, but now the problem with this failure point and why I can't demonstrate it now is because this was one of the first failure points that I've experimented, and ever since or after here, I changed the app server quite a lot. So I couldn't roll back to the original app server that I have with this. So that's why I can't live demonstrate it, but I did take screenshot of this. Actually, this entire journey is posted and documented on my LinkedIn. But then, yeah, I couldn't roll back to the original app server with the code for this experiment, but I did take screenshots. And as we can see, there's two connection patterns that I experimented or that I learned from it. There's the wrong way and there's the right way. Then you will see exactly what I mean by that. So with what I wrote here, the connect to RDS function is connecting to the database with per request. Per every request, the a new connection is created. So there was no pooling at all. This worked. This worked quite a few. It worked when I did it once, twice, and three times. But then when I decided to send 100 concurrent requests, the app just broke. And I will show you, I think the screenshots are over here. Yeah, there you go. When you send 100 concurrent requests with the function connecting to the database straight, it just breaks. You get an error code, or like as you can see here, the error code saying that the database is rejecting new connection because we've hit the 75 connection limit. So this basically just taught me how connection pooling isn't just about performance optimization, but it's essentially for system stability. But even with proper pooling, you can still have problems if you're not careful. And we saw this with our original Docker zombie container where we didn't close the connections after 5 connection limit that we've placed, and the app just started hanging. And under normal load, you can see the pool efficiency reusing the connections, but without it, it becomes a problem. And yeah, so that's basically it. That's what I wanted to show with this. And this exactly what feeds into our zombie container, as I was saying, because the connection leaks plus the resources constraints equal silent system death. So the key insight is that you need real-time visibility into connection pools. All right, so those were just the different failure points that I wanted to demo. And I just wanted to say that, these systematic failure matters beyond just me demoing it to you guys, because these exact patterns cause production outages in big companies every single day. The zombie container, for instance, that's like payment platform that appear healthy to monitor while silently dropping customers transaction. The connection exhaustion, for instance, is like e-commerce sites that crash during Black Friday, traffic spikes when database can't handle the load, provider failures where microservices architectures that work perfectly in staging but fail desperately under production concurrency. The difference is, I feel like it's just taking systematic approach to failure analysis instead of waiting for late night debugging or 3 a.m. production fires. I deliberately triggered these failure in controlled environments to understand exactly how they behave, what the symptoms look like, and how to build proper safeguards. Each of these four failures that I experimented, they taught me something that no tutorial or documentation ever could. And I'm glad that I did this, because without doing this, I wouldn't have learned. For instance, that the net gateway placement that hangs application, it should be in a private subnet and not a public subnet. It's a silly mistake, but it's one that I had to learn by doing it and by seeing it myself. The resource or a health check, for instance, that prevents mysterious outages, and also the connection pool, which is the most important one because it helps monitoring exactly what reveals the problem behind impact or impacted customers, I mean. And then the credential caching as well that I didn't mention, that prevent SDK failures under load. This systematic approach to breaking things has completely transformed how I approach infrastructure design and troubleshooting. All right, and in closing, I just want to say that the whole approach of this was for me to see that infrastructures do fail in predictable patterns, but most developers never see the truth until production. By systematically breaking things like I did, I learned how systems actually behave under stress, not just when they're supposed to work in perfect conditions. And yeah, that was just the fragile store, this project that I've been working on, and the stuff that I learned from it and how to prevent them. All the code, the documentation, and failure analysis has all been documented on my LinkedIn. I'll put a link in the description if you're interested in the journey. And yeah, that's it for me. If you're building production systems and want to discuss failure patterns, please feel free to hit me up on LinkedIn, or yeah, my email address as well. All my information are on my LinkedIn. I'd actually love to hear from what you guys have done, or connect with how we can build something together from this. And yeah, that's it for me. If you found this systematic approach to infrastructure failure analysis useful, then yeah, hit me up and subscribe or like this video, which I doubt that will happen because this is gonna be posted privately. But yeah, subscribe if you don't mind, and I'll will keep posting more of my project like this and what I learned. And if you watch this video till the end, thank you so much. And remember to like and subscribe. And yeah, that's it for me. Cheers.